Question 4. The diagram shows the graphs of the functions f of x and g of x. It is known that the integral from x equals a to x equals c of f of x dx equals 10, the integral from x equals a to x equals b of g of x dx equals negative 2, and the integral from x equals b to x equals c of g of x dx equals 3. What is the area between the curves y equals f of x and y equals g of x between x equals a and x equals c? We can treat this as a composite area problem. Now the question is asking for the area bounded by the curves y equals f of x, y equals g of x, and the vertical lines x equals a and x equals c. Now I've highlighted the area in question here. Now we need to apply the facts that are given. So it is known that the definite integral from x equals a to x equals c of f of x dx equals 10. And that's this area here. So it's bounded by the x-axis from x equals a to x equals c, right up to the curve y equals f of x. So this whole region here is 10 square units. So it looks like the area bounded by the two curves and the vertical lines is this area here. We need to subtract out this area here, but then add on this small area here. So if this is 10 square units, this area here is given by this fact here. Now, while it's a definite integral, it's also equivalent to the area under the curve because it's above the x-axis. So this is signed area, but because it's positive, we can just treat it as area. So the area of this particular region here is 3 square units. And the area under the x-axis from x equals a to x equals b and the curve y equals g of x is given by this definite integral here. Now this is signed area and it's negative 2. But if we're treating it as unsigned area, and that's what the question really is asking, this area here is positive 2. So to get the area of the highlighted region, we take 10 square units, subtract from that 3, so 10 minus 3 is now 7, and we add to that 2 square units. 7 plus 2 is equal to 9. Therefore, the correct answer is option C.